John Hamling is here. We'll chat with John and then try and catch up with Dan at some point. John, how are you?
God, I'm doing great. How about yourself?
Wonderful. So you get up every day, go to work, and your job is making integrated projects work better, I understand, huh?
Yeah, so how I like to look at it is my job is figuring out how to produce North Dakota energy, produce U.S. energy better.
That's pretty nice. And what is an integrated project exactly?
Well, so what I really look at doing is taking some of the conceptual work that we do here at the ERC, taking some of the laboratory results, the modeling, the simulation work, and really bringing them to the next level and applying those concepts in the field as part of a pilot or a demonstration to hopefully, if successful, bring it closer to commercialization so it becomes pervasive in industry and can really help the production of energy.
And the Energy and Environmental Research Center at the University of North Dakota is world-renowned for doing this kind of work. I mean, this is the experts look to EERC to get this done, and they do it right. So let's talk about the BEST project. Love the acronym.
Yeah.
The BEST project stands for Brine Extraction Storage Test. Tell me first what brine is. What is brine as it pertains to the energy world?
Yeah, so brine is essentially a higher salinity water that's in a lot of geologic formations. So typically it's not an underground source of drinking water, which would be a freshwater aquifer. Brine would be what's in the other formations, whether it be a saltwater formation, or brine is often associated with oil and gas production as well. For example, Bakken production, for every barrel of oil that's produced, there could be up to a barrel or more of salt water that is produced with it, or brine that's produced with it. And it can be on the order of a few percent salt to upwards. Some of these formations produce 30 or 40% salt, or 30 or 40% of that water is salt. So up to 400 times saltier than seawater.
Wow. Is there anything good in brine?
Well, that's what that's part of this project, and that we're looking at, or taking a look at. And one component of this project is a testbed facility that we've been working with the Department of Energy to set up. And as we're handling fluids as part of this project, we'll have the ability to blend and tailor brine compositions to replicate waters of almost any geologic formation throughout the U.S. and throughout North Dakota. And what we're taking a look at is helping to test and enable the development of next generation brine treatment technologies, and helping technology providers to develop techniques that can take advantage or to try and treat this brine for some sort of beneficial use. Beneficial use could be anything from perhaps treating it in a way where it could be used for cooling water from an industrial process. It could perhaps be used perhaps recycled and used as a fluid for hydraulic fracturing for stimulating wells to increase additional oil production. It could also mean taking advantage of some of the chlorides in the sodium chloride or the salt that's in that fluid to do something like maybe produce hydrochloric acid that can be used to help prolong the life of some of our oil and gas producing wells, or even taking a look at is there potential for rare earth elements in that fluid where we can help that could be useful for the production of electronics or battery technology.
Very interesting. So when we use it now, do we use it now? What do we do with it now? I mean, you've described some great ideas there and ways that it could be used, and obviously that's why you're doing the research you're doing, but what happens to it now?
Yeah,
store it?
Yeah, so most brines produced, if you're over about 180,000 or nominally 15% salt, it's not really. There's not a technology right now that's broadly economic to treat it in most areas. There might be some niche markets out there, but the technology isn't quite there yet. So the majority of the brine that's produced with almost any industrial activity is injected through a saltwater disposal process and essentially disposed and injected in deep, high salinity geologic formations. What we really want to do is but to do that, there's an energy penalty associated with it. It costs money to handle that fluid and to re-inject it. And so if we can treat it, if we can develop technologies that can treat it, not only might we reduce the amount of fluid that we have to inject into a deeper formation use less energy. But if we can find a product that has some sort of beneficial use, maybe we can find some economic offsets or other benefits for handling something that we need to handle anyway.
Yeah, that's really interesting. And it's great. We're chatting, by the way, with John Hamling, who is Assistant Director for Integrated Projects with the Environmental and Energy and Environmental Research Center at the University of North Dakota. That's where they're located up in Grand Forks, talking about the brine extraction storage test project that is underway. Now, when you do a project like this, are you in the field? Are you on campus in the EERC facility? Where do you do it?
Yeah, so the short answer is both. When we started getting involved, we were first awarded a phase one project, which was really to develop a design, a feasibility study, and an implementation plan to take some of these concepts that we've been developing in-house and apply them in the field. And we were one of 5 organizations nationally that were awarded we were one of 2 organizations nationally that were awarded a phase 2 project based on the results of phase 1 to take those concepts and go out and apply them in the field. So over the course of the last year, we've been working with the Department of Energy, who's been a primary funder of this work, our key project partner, Nuvera Environmental Solutions, at one of their saltwater disposal sites near Wofford City, North Dakota. And we've been working to drill 2 additional wells that we're going to conduct the testing, some of our tests in the Dakota Formation, and also do some work in the Broom Creek and Amsden Formation, which are both saltwater disposal targets. Broom Creek and Amsden are also potential CO2 storage targets in the state. So we've been working heavily with a lot of North Dakota companies, a lot of individuals here at the EERC, a lot of folks in the western part of the state to go out and get these wells and the infrastructure designed, built, installed, so that we can start our testing early in 2019. So we think we'll be operationally ready, and we'll start some of our field testing, particularly on the reservoir testing side, here in January.
Last question for you. Everything goes as planned. It kind of tracks like you think it's going to track. When does this technology bust out of EERC and become widely used?
Well, that's a great question. So I think the work we're doing right now is to not just develop a single technology, but to really create an environment that fosters innovation, and that we can work with different technology providers, different companies, and provide them with the real-world operating data that becomes so critical in bringing these from a lab scale or a bench scale concept and applying them to the field to understand what are the potential challenges, what do you have to do to keep these technologies operating in challenging environments, and in the oil fields of western North Dakota, in the oil fields of the Permian Basin, anywhere in the country, and give them that data that they need to look at. All right, how do we bring this closer to a commercial application?
Well, keep up the good work. Our best to everybody at EERC, and we appreciate the update.
All right, we very much appreciate it, and thank you for having us on.
You bet, John. Thanks a bunch.